Start recording. Okay. Now, bring this back. Bring this back. So we're back now, and we're looking at the this hint at the wiring here, and this is the picture of the schematic, and this would be the hints of the wiring of it. So this is now on the recording. If you want to go back, you can look at it. If you just came, you can review this. But this is that NPN transistor. Okay, that's right down here. Whoops. Right there. Okay, so that transistor is this guy, and it's a switch, and it acts like a switch, and at 0.7 volts or greater, it allows current to flow from top to bottom through it. At 0.7 volts or less than 0.7 volts, it stops the flow, and that's why this is in red. And so if you set up an RC time constant, this turns on and gives you 24 volts, and then when it turns off, you sag down to 0 volts, but not immediately. But if you have 2 or 3 seconds before it gets to 0.7 volts, you can pick a resistor and a capacitor that'll give you that delay, and that's the delay that you want at the end before you go the other way. So I'm requiring you to have a delay in there. You cannot just build a circuit without the delay. You can't start going one way, and then when it hits the limit switch, it goes the other way. I will not allow that this year. I did in the past, but I'm not going to allow it. You have to build this in, okay? All right, so that gets you started. And I will put this on the syllabus, a little bit more explaining it, but basically that gets you started. Okay, so anyway, so I passed around some Bodie plot graphs, and I think I told everybody to take 5, and there's still some left, but I don't think I have enough for everybody to take 5 of the people that are left. But let's just split up how many people still don't have this graph paper, and I'll give you a few, and we'll give you more after today. Okay, so there's some, there's some, there's some, and who else? I ran out, so maybe you want to borrow 1 or 2 from somebody else. And after today, I'll have more. But today I am. I didn't run more than 50, and I didn't know how many people are going to come. So anyway, but the stuff is handing around. All the homeworks are being handed around. There was one that I didn't have a name on, so please check to make sure that if that's yours, put your name on it, give it back to me, and highlight it, and I will give you the grade. Okay. So now this is worth 10 homework questions, and there's 10 questions in this. I'm going to show you where it's at. Hang on it. So you go over to the EET course, which is under courses EET 4450, and that's where you find this again. And if you're ready to take this EET 4450 class, that's a senior level class. Most people take it at their senior year, but we're doing this the same as they do it, and that's for electricals and mechanicals. But like most people, you'll see this again. I don't want to make a big deal about it, but I'll give you the basics for what it is. So this is under examples, okay? And then under examples, you click on, okay. So okay, now I want to go back here, and this is a downloadable, and then under examples, Ted, shoot. I'm going to extract it. Well, let's do it again. I don't know what the heck is going on, but let's just do it again. Okay, try this again. Examples. Extract all. Do you see that being extracted? No atoms matcher. What is going on? I don't know. Something's going on. I don't know what it is, but something's going on. Let's go back and do it from the work 6. Okay. Okay, so this is homework 6. And that piece of paper that I gave you is, instead of this, I'm going to go back and get I'm going to go back and get it. It's right here. Okay, so this is your Bodie plot graph, and this is what that looks like. And let's go back and let's shrink it down a little bit more. Spin it, and then I want to take that and copy it into these guys. So now I want to take and empty and open a picture right there. Okay, so then I want to spin this. Rotate, Ted, rotate. Every time I do this, I have to reset my, okay, setup. So I want to spin it 90 degrees. I want to select all, and then I want to do what with it? I want to spin it 90 degrees. Oh, brother, how do you do that? Rotate. Watch the teacher sweat. Open. Once I get it, it's easy, but it's just getting it going. I'm going to do it this way. I'm going to rotate it around. Okay, and then I'm going to copy it. Then I'm going to paste it into this guy. Okay, now I'm going to start this from scratch. Didn't work. Okay, download. Save. Now see if I can bring this in. open. Add image. There you go. Now add image, and then I'm going to add it. This is open. Yeah, this is it. This is the way you do it. Sorry about that. You're all hoping he's going to not get it done, and we're going to get out of here today without having to do this. Not yet, but we'll. Now I gotta do it again. New, not okay. Now add image. Open, add image. Semi-log. Okay, open. Yeah, this is it, and this is the size of it. So I bring it down to the size that I want it as. And then I flip it. I go around until I. This. So now I've got it, and now I want to make it a little bit bigger. Get rid of this guy. Okay, now this is it. This is my image. And I can mark on it or do whatever I want to with it, but this is basically what I got. Now this is the piece of paper that you've got. Now on it, let me see if I can come over here and way to the left with it. Okay, so this is the piece of paper that you have, and it is a. I want to go all the way to the left. And I want to see that little thing in the bottom. Let me do it again. Sorry about this. It's going to take a second. We're gonna do this right, and we'll get it. But just click on this and open, and then I do this. Shrink it down. I want to shrink it that way. I want to shrink it. Do it again, Ted. Sorry about this. Add image. Open. Click open. Okay, now I've got a fresh one. I want to make it smaller. And I've got it now, and I do not want that one in the background. Let's start the whole thing from scratch, and then I'll get it right. Okay. Let's start again with this, right? An image. So it's basically putting you a piece of paper just like what you have on the screen, and then I can work with it. Okay. So this is the image that I have. Okay. Now it's. There's 90 degrees. So now that is my image that I've got. Now, it's not quite square, but so be it. All right, so you have a watermark in the lower left-hand corner, and now you look at this and you say, okay, now what does this mean? Well, basically, this is a logarithmic scale on the x-axis, and on the y-axis, it is a linear scale. If you look at it, you can see that. This scale right down here is a, I want to get rid of this. Okay, I want to get rid of that. So down here in the corner is your watermark. So that's in the lower left-hand corner. Now, if this is 0.1, this is B1, and this would be 10, this would be 100, this would be 1,000, and this would be 10,000. All right? So what you've basically done is you've shrunk a picture of a variable into, from the low end to the high end, you see a lot of activity down here, but up here you see it kind of, you follow me? It gets a little bit more, you scrunch things up as you go further up, okay? If you've ever heard of like a an earthquake, when they talk about a, the severity of the earthquake, it's on the logarithmic scale. So a 7 is 10 times more than a 6. And a 6 is 10 times more than a 5. A 5 is 10 times more than a 4. So if you have a 7 on an earthquake scale, that's a huge earthquake, okay? So anyway, this is a logarithmic scale on the x-axis. It's a linear scale on the y-axis. And what we're trying to do with this scale is we're trying to scrunch things in as they go higher. But we're trying to show a large breadth of something, and that's what Bodie plots are good for. They scrunch in on the high end, and on the low end, they basically show you a lot of detail. So there's a lot of detail down here. This end gets scrunched, but we don't care because we want to see over a wide breadth what a variable looks like, okay? We want to see when something goes high and when it goes low. That's what we want to do. We want to see, based on this variable on the lower side, the x-axis, what the y-axis does. Okay? Now, that's the graph. This is the problem. This is the problems that we are given. Okay? And this is typical of Bodie plot problems in general. And there's 1, 2, 3, 4, 5, 6, 7, 8, and there's this is 9. There's 9 of these. 1, 2, 3, 4, 5, 6, 7, 8, and then there's a 9th one. So there's 9 of these. There's not 10, there's 9 of them. If you can do these, you'll be able to do anything that I throw at you. I'm not going to make this hard. I'm not going to throw you any of the weird stuff. Now, there is a tutorial on this in that same area, but I'm going to give you enough, basically, just if you follow through with what I'm telling you, that you can read the tutorial if you want to, and it won't confuse you, but it's the same thing as what I'm telling you. So basically, what you do is you number the x-axis, and you say, what if it goes bigger than 10K? What if it goes to 2 meg or 10 meg or whatever? What about then? Well, basically, at that point in time, you go to a 8. This is 1, 2, 3, 4, 5, 6. This is a 6-axis Bodie plot. You would go to an 8 or a 10 or a 12. And how do you do that? You just dial up on the internet and say, give me a 12-axis semi-log graph, and it will. You used to have to go to the bookstore with this, and you had to go get your set of 20 of these sheets, and you had to keep them and guard them, and then when you had to hand in, you would do the graphs and all that kind of stuff. Well, today, we're kinder. We've got the web to generate these, and there's a copy of this on my web sheet, or on my web, and you can copy it and make as many copies as you want. And I'll continue to give you copies of this. I'm sorry I didn't get more this time, but there's 8 there's 8 pictures that you owe me, okay? You can do them each on a separate sheet, or you can do them however, and I'll give you more next time. So you can work on these, or you can print them off yourself. I don't care, right? So the goal here is to pick an x-axis, or excuse me, an axis across what we call our 0 point. And it can be anywhere. It can be here, it can be here, it can be here, but it's someplace usually in the middle, and I'm going to pick right here, and I'm just going to draw a line across it. And that's my 0 point, and that's 0. Above it is plus numbers, and below it is minus numbers. And now you can pick, you can go 10 at a time, you can go 20 at a time. I don't care. I usually go 10 at a time. So this would be 10, this would be 20, this would be 30, this would be 40, this would be 50, this would be 60, and below it is a minus 10, minus 20, minus 30, minus 40, minus 50, minus 60, okay? Minus 70 if you want. So again, lower left-hand corner is the watermark. Why do we pick it lower left-hand corner? Because we start with the number 1 or 0.1 here, And you can start with 1 if you want. You can leave out the 0.1, but usually we put the 0.1 in. And this would be 1. Now, where is 2? Good question, right? This is not linear. 2 is right, 0.2 is right here. This is 0.2. Where's 0.3? It's the next heavy line, 0.3. Where's the next one? 0.4, 0.5, 0.6, 0.7, 0.8, 0.91. Do you see how as they get closer to 1, they get closer together? This is a logarithmic graph. Okay? You say, what is a logarithm? Say this about 10,000 times and you'll get it. A logarithm is an exponent. Say it about 10,000 times and you'll have that. Okay, so if you don't know, if you don't remember, a logarithm is an exponent, 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 and you will eventually, it'll soak in. Okay? I promise you that will help. If you can't remember what a logarithm is, say, a logarithm is an exponent, a logarithm is an exponent. It eventually gets through. It takes a while, but it gets through. Okay, so everybody got that. Now, what are we trying to graph here? We're trying to graph the amplitude of a function over a frequency. Okay, but we don't call this f down here, we call it s. So instead of reading chapter 10 and saying, we're looking at j omega, we forget about j omega, or 2 pi f times j. Instead of that, we call it s. We forget about all that 2 pi f stuff and j, and we just call it the letter s. Okay? Isn't that neat? That's what we do. That's the rule. So that's rule number 1. Instead of plotting something against frequency, we plot it against s, the variable s. And eventually you'll figure out what s is. That's yet to come. But I don't care. We're just graphing s versus... You just pretend it's frequency and you're good. If I call it frequency instead of s, you accept that, right? I say, as you go higher in frequency, you're going higher in s. S really is a real number plus a 2 pi jf, or 2 pi fj. So it's a partially this and partially that, but for today we're going to say, we forget about that part. Any questions about S? I know you're, what is he telling me? I'm telling you a bunch of rules, and basically these rules are pretty easy, but you have to follow them exactly, okay? You have to put blinders on to everything else and say, now why is he telling me this? And say, I don't care, I'm going to get these rules, and then I'm going to follow these rules, and that's good. Now, we're going to skip number 1 for a little bit. We're going to skip it because it's got a special... It's got 2 parts in there, and we're not going to worry about those 2 parts here right now. We're going to worry about this one right here, okay? Now, this one has some variables over it, and the rule is this. You get it into this form, okay? You get it into this form. It's a 1 plus s over something, okay? Now, if it's in the numerator, it goes up. If it's in the denominator, it goes down. Why is that? As s gets bigger in the denominator, my value of this overall thing gets what? Smaller. So you basically say, if the s is in the numerator, it goes up. If it's s in the denominator, it goes down. S in the numerator, it goes up. S in the denominator, it goes down. And how fast does it go up or down? Well, it goes up or down basically at 20 dB per decade. And I know that's going to blow everybody's mind and say, what is that? What did it say? 20 dB per decade. What does that mean? Well, what it means is you go up 20 or down 20 for every 10 you go over. So if I start at a point and I go over 10, I go up 20. So there would be my point. Here, if this is my point, that would be my point. and I would draw a line from that forever. So 20 dB per decade is, you find your point on the x-axis, you go over 10 and up 20, or over 10 and down 20, draw your line, and it just keeps going. That's why the straight edge. Okay? Make sense? What does 10 dB per decade mean, or 20 dB per decade mean? You go over 10 and up 20, or over 10 and down 20. And then you put a point, and then you draw all the way out. So, if there is a 1 plus, you start at 0 and you go up. If there is not, if there's just an S, you go from a straight S is different from a 1 plus an S, okay? So a 1 plus an S, you start at 0. If it's just an S, you don't, okay? Now this is what happens if it's just an S term. You start at, you cut through the x-axis at 0. In other words, at 1. You cut through, so for this S right here, you cut through the x-axis at 1, and you start, if it is in the denominator, you start up here and you go down. So you start up here and you go down. And you start up here, and I'm not drawing lines very straight today, but this is how you do it. So this is how you do it. Okay, so that takes care of the S line. That's just the straight old S. Numerator, go up, denominator, go down, and this is a denominator, so you go down. Everybody follow that? We're working just with that S right now. Now, this is a S plus 100. So at 100, this starts doing what? At 100, where is 100? 100 is right there. This one is a 1 plus an S, so until 100, it's 0. But at 100, it starts going down. And it goes down at the rate of what? 20 dB per decade. Why is that? Because it's in the denominator. If it were in the numerator, it would go up. Everybody get that? Okay, so this one is going down. So that is the 1 over S plus 100. Now this is a 1 over S plus 1000. What do you think about that one? What would that one do? You start at 1000 and you start down. Everybody see that? You start down. Why? Denominator. Very good. Now, what do you do with this whole mess? Well, you're not done yet. There's a constant. The constant here is what? 100. So now you take 20 log 100, and that is my offset. What is 100? What is the log of 100? It's 2. If you don't believe that, put it in your calculator and punch in log parenthesis 100 equals 2. Isn't that right? Any questions? Any comments? This is your offset. What is the log of 100? 2. A logarithm is an exponent. What is 10 to the 2? Right? 10 squared. Log base 10. This is log base 10 of 100. 2. So what is my offset? What's 2 times 20 is 40. So I go up here, and this is my offset. Now I'll put my offset in a different color, just to make it a little more colory or whatever you want to call it. But let's just put that in there, okay? Put it in red. So let's put the offset in red. Now I add these lines together, and I'm going to do that in, let's do it in blue, okay? Now I'm going to add these lines together, and I'm going to do it across from left to right. So basically at this point in time, I'm going to add the lines. So what is 20 plus 40 is 60, right? And it comes down like this. And it keeps coming down like this until I get to here. And what does it do at this point? It starts going down at 40 dB per decade instead of 20 dB per decade. So at this point in time, my line looks like this. And at this point, it starts even more of a steep descent, and it goes off the graph like that. And there's your answer. This is what we're looking for right there. There's your answer. Now, what is this good for? You can very quickly look and see where this function is high and where it is, where would this be high at? Very low frequencies. Very, very, very low frequencies. Where would it be low at? Well, anything above 100 is really low, okay? So if you wanted a high output, at what frequency would you, if this were the circuit that you're going to add, this is the Lego that you're going to add to your other circuit, what would you expect the output to look like? It would look okay at low frequencies, and it would look terrible at high frequencies, wouldn't it? This would take those high frequency signals and just throw them in the wastebasket, and it wouldn't let them through. So you see, this is a low-pass type device, high-pass cutoff. You say, what else can you do with this? Well, you can have a notch. You can have it where there's a middle, and then it goes. It's high here, and it goes down, and it goes back up. You can have it where you can have a high pass, or you can have it all kinds of different. You can see that on a graph. Now, this is not only good for electrical circuits, this is good for all kinds of, you see this in all kinds of engineering drawings. They show you this linear on the y-axis, log on the x-axis, semi-log. You'll see this in a lot of graphs in not only electrical circuits, but in a lot of different explanations of things. So this is getting you used to looking at a semi-log graph. How do you construct it from electrical terminology? Right here. And don't worry about the S. I'll just give you the S, and it shows it to you, okay? So basically, yes? How's it going? This right here, this offset, the offset is 20 log this number, the constant. It's the constant out in front. It's that number right there. Yep. Now, if it's a power, that's a good question, because for amplitude, this is an amplitude graph. Amplitude is 20 dB per decade. Power is 10 dB per decade. Forget about that for right now. And there's also a phase shift drawing, which I'm not going to get into. That's another drawing, a phase shift drawing. It shows you the phase shift. I'm not going to try. Okay? So this is just a set of rules. Okay? It's all it is, set of rules. We'll go through these and we'll practice them. Just follow the rules exactly the way that I'm telling you, and you'll get your homework points and you'll get your test points. There'll be 2 questions like this on a test. They're easy. They're really, 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 really easy, but you have to follow them exact. You have to follow the rules exact. Now, what can I do to make this harder? Well, this is in its final form because it's the 1 plus the S over something. you have to convert it to this form, or you have to get it to the 1 plus s over whatever. They've done it again here. Here they did it again. Here they did it again. Here they did it. Here they did it again. Here they did it again. Here they didn't do it. Okay? So I can toss it to you either way. So you can say, okay, now I've got to get it 1 plus s over 100, and that changes the constant. It changes the constant in front of it. So that's the only thing. For this one, you've got to do what? You've got to divide whatever. So will he give it to us like this, or will he give it to us like this? The answer is, I don't know. If I'm feeling good that day, I'll give them to you both like this. If I'm feeling bad, I'll give you one like this and one like this. Or I'll give you one like this, which I probably won't do. But I'll show you this last, because this is I don't know why I put this in first. I should have put it in last, but anyway. So everybody kind of got this. Not a big deal. No. 8 sheets and you're done. It's just a bunch of rules. Okay? Let's do another one. So here's my drawing. And here is my function. So basically, what do I do with this one? First thing you do is 0.1, 1, 10, 100, 1,000, 10K, 100K, right? 10. And how do you know? How do you know that this is right? Well, where they get fat, where they're fat, that's where you get your one again, where it gets fat. Okay, so that's your clue. Where it gets fat is where you put in your one. Where is it fat? Left-hand corner. Fat again, that's your 0.1, 10, 100. Where the lines are farthest apart is where you put your 1, your 10, your 100, your 1,000. Okay? And if you can't find those numbers, think of it like this. Where the heavy lines are your main numbers. So this would be 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. And then they really get small, 0.7, 0.8, 0.9, and then 1. You'll find them, but they get closer together as you get higher numbers. Why? Because it's a logarithmic graph, okay? Which is an exponent, okay? And if you really want to know, this is exactly how a slide rule is built. If you take a slide rule apart, what you're actually doing is you're adding numbers as you slide across, which is how we used to use. You're looking at somebody. I'm in the last of the last. I was the last class in college that did not use calculators. I used slide rules all the way through my 4 years of college, okay? Slide rules are exactly built like this, and you're sliding back and forth and you're multiplying numbers based on exponents. That's all you're doing. That's how it's built, and it works. We always talked about 3 sig figs, significant figures, and you had to keep 3 sig figs. You're supposed to get 3 sig figs. Anyway, do you ever feel old? That makes you feel old because we know how far calculators have come. But anyway, let's look at another one here, and that's why I like to have a good calculator, because you know what a good calculator will give you, and this is a course where it really does help. So, what is the constant in front of this one? It's 1. So, Draw our line across here. Let's draw our line across here right there and this time. I don't really care whether it's high or low or whatever. Now this is, it's kind of up to you where you draw this line across. Okay, you draw it a little higher, a little low, but usually right around the middle someplace. This is 0. Did I say 10 before? Yeah, let's do 20, 30, 40, 50, 60, et cetera, et cetera. Minus 10, minus 20, minus 30, minus 40, minus 50, minus 60. So you're already, if you got some of those pieces of paper, you already got homework assignment number 2 done, 1.2 done. You're an eighth of the way there, if you drew it, okay? Now this is this one right here. So now I've got some in the numerator and some in the denominator and none that are just plain S. So I don't have any that are starting and then going down through 1 like I had before. But I have 2 in the numerator and 2 in the denominator. Which one do I pick first? I don't really care. I can concentrate on the numerators or I can concentrate on the denominators. But I'll just concentrate on this. Where does this one right here start? 1 over S plus 10. Where does it start? At 10. It's glaring at you. And how does it go up or go down? It goes up. Okay? Why? Because it's the numerator. Okay? So now you've got that line. Okay? This is the 1 plus S over 10. That's that line. What about the 1 plus S over 100? Starts at 100. To go up or go down? Goes up. Okay, now you've taken care of the numerator. What about the denominator? What about this one right here? It's at 1. What does it do? It goes down. What about this one? Adam? It goes at 1,000, right? What does it do? Up or down? Okay, very good. Okay, so what else do I have to do? What's my constant? What? 1. What's the log of 1? Log base 10 of 1? 0. So my starting point is 0. I don't go above my constant, there's no offset. Everybody see that? So now my answer in blue will be just these. There's no offset. This guy is easy peasy. Okay, so let's go and get the blue. So I'm trucking along here at what? Where do I start at? Yeah. Start at 0. You start at 0, you start at 0, you start at 0, you start at 0, and you're down to here, and you start doing what? Why go down? Go down like that. See how much fun this is? Now what do you do? Well, you got 20 to going down and 20 going up. What do you do? Very good. Now what do you do? Now what do you do? Josie, what do you do? What do you do now? You got one going up and one going down. What do you do? Instead of going up anymore, you got this one combating it. So what do you do now? You go flat. Yep, just like that. So this is your classic notch. High over here, but in the middle you got a notch. Okay? You say, when would you ever use something like this? I don't know. But let's say you have a piece of metal at or let's just say you build a stand for let's just make it like a sign along Interstate 80, okay? And all of a sudden you notice with a certain velocity of wind, it starts to do this like crazy, okay? And it does that constantly. Now, what would you do in that case? You'd find that frequency and you would say, I add a stiffener that would counteract that frequency. This is what you're doing when you put a stiffener into a signpost. You find the frequency at which it works and you put something in to counteract it. That's exactly what you're doing. You're putting in a notch filter. You say, well, I wouldn't have to do this to make something like that. No, you just grab you grab a piece of steel and you figure out what that frequency would be and what it would take to make it happen. And you might use, you might just use a piece of steel and anchor it into the ground. You might do something else. I don't know what you do, but that's a mechanical version of this. Electrically, what you would do, you would add a resistor and a capacitor or an inductor to make it notched, okay? You would do electronically, what they do in the not the real world, but in the non-electrical world, the mechanical world, using sound deadening equipment and stiffeners and other kinds of things to do that. And you say, does this happen in other kind of things? Yes, it does. I used to be able to hear pretty well across the frequency range, and in my age, there are certain frequencies I do not hear, as well as others. Some I hear pretty well, some I don't. And you could be in that frequency range that I cannot hear spit. So you could be talking and I could be standing here and I could say, now what did you say? 3 times. Some of you I hear pretty well, but it is a frequency-based scenario, and some of you hit right on it. I mean, I can tell. Any questions about the notch filter? I got a notch filter in my head that may not work quite well. I didn't ask for it, but I got it. Yes, sir. Huh? You combine them. You make them all one. You just put them all together. You've got to make them all one. You got to coalesce them into one. Any questions about number 3? All right. Do you want me to work more of these, or do you want to try them on your own, or what do you want to do? Now, here's one that gets a little bit more jazzy. What's more jazzed up about this one? It's not ones all the time, is it? This is where you got to find other numbers, right? So now you got to do that. Okay. So let's do this one. One more. Oh, and by the way, up here, number 1, you ignore the 1. You use the S plus this number, forget about this number. You take the rule of thumb is you take the bigger number, and if this one is small and this number is bigger, you make it the other number. So this one, you forget about the 1, you use the 100, okay? So you're going to say S over 100 plus J1. You basically ignore the smaller number. That's the rule of thumb. Now, this is not an exact science, okay? And there are some caveats to this because, this is just kind of a rule of thumb, how you draw it across the broad frequency range. There are some places where this might go up and then come back down. And it's not, if you read the rules, it's not exact and you smooth these corners off and all that kind of stuff. I don't care. This is good enough. If you can do this, all the rest of it is icing on the cake, and I don't really care. But you can read through the rules and you say, this is the basic rules, yes. The rest of the rules they add a little bit of variety, but if you can do this, you're fine in my book. So that's all you have to learn. Now, the sad thing about this is you get this about 3 times, 4 times. You get it in this class. You get it in the electronics class. You get it in 3250, and you get it in 4450. So by the time you get this 4 times, you'll have heard this explanation about whatever. So if I'm still around and I'm teaching in 4450, and you're a little bored because you've heard it about 3 times before, so be it. Okay. It's a classic thing to learn, and you learn it again, you learn it again, you learn it again. This is one of those that I don't want to make bigger than it really is. I don't want you to get all excited. Oh, I know about multiplies. Yep, good for you. But you'll learn it, and then you'll learn it again, and you'll learn it again, and you'll learn it again. Every course has a little bit on Bodie plots, it seems like. So please don't shoot me if you have this again in about 3 different times and say, well, he said, this is, these are the rules, these are the basic rules, all the rest of them are icing on the cake. You can do them if you want to. How's that? Now, I'll give you another clue. The constant, some people ignore. They just say, heck with it. They don't do the offset. So I do the offset. I'll give you a clue. I do not grade off if you don't get the offset right. I do grade off if you can't get this part right. If you can't get the offset right, yeah. You basically see the shape of the graph. The offset is just an offset to the graph. That's, if you can do this part, you get your 10 points on a test question. If you get the offset right, you get 10 points plus thumbs up or whatever. But I don't grade off for if you miss the offset, I don't grade off. If you can get this part, you see the basics. Okay. Okay, one more. This is number 4. Okay, let's do it. I'm getting better at this. It takes a. Sorry about this. Try this. They lie about their it's 89 degrees where it comes in best. Okay, so now we're back and we've got one more, and let's do this one and we'll be done for this today. Okay, so this is again going to get back to my black color. Rid of the lagoon. And we're concentrating on this one right here. This one right here. So basically, come over here and we do our thing. $10, $20, $30, $40, $50, $60, et cetera, et cetera. And now we put our numbers down here, 0.1, 10, 100, 1,000, excuse me, 110, Ted, 1, 1.0, 10, 100, 1,000, 10K, et cetera, et cetera. Okay, so now we've got that, and now we're going to have to find these numbers, and the number is 1/6, or point, what is 1/6? 0.166, right? So what is 0.166? This is 0.10, 0.166 is about right in there, isn't it? And is it a numerator or denominator? It's a denominator. So now you've got to find 1.6, which is about right there, and you're down 20. You got to draw a line. And that is that number right there. Now, the 1.88 is what? 1.88, and that's right about there. Same thing. Okay, so 0.166, 1.8. What about this? S squared. Now you've got an S squared term. Now, what do you do with that? It cuts through 0 at 1, and it's a double, so it does what? It goes at 40 dB per decade. So basically it goes like this. Okay? Everybody agree with that? Like that. It starts at minus, I should have written it better. It starts at minus 40. It starts at minus 40, goes through 1, goes to plus 40. By the time it gets up here, it's at plus 40. that. Okay, now, how do you add all these up? Oh, and what is my constant? It's 40 again, right? So my constant is 40 again, so let's do the constant. So I've got a constant at 40, and I'm going fast this time, so I'm a little sloppy. But now my blue. What is my blue? What is my output or my answer? Okay, so I am 40 minus 40, so I start here, but I start up at 40 dB per decade. So I'm parallel, until I get to here, I am parallel with this line, and I am going up at a very fast rate. So I'm going up like this. At this point, I do what? I'm still going up, but I'm at a lesser rate, and I get to here, and I am at a flat. At that point in time, I'm flat. At this point right here, I turn flat. I'm at a high rate, then I'm at a lesser rate, then I'm flat. Looks pretty crude, but that's exactly how it's done. Any questions? Any comments? Yes, sir. What, 166? Okay, so 1 divided by 6 is 1. Did I do it? I did it wrong. 1 divided by 1/6 is 1 divided by 6 is 0.166. Okay, right? 1 divided by 6 is equal to 0.166. Isn't that right? Okay. So now I go over here and I find where 0.166 is. This is 0.1. I got to get rid of that window. I got to get rid of that lagoon. Okay. So this is 0.1, 0.10. This is 0.2. This is 0.3. So 0.166 is about 3/4 of the way through from 0.1 to 0.2. I still didn't get you. What? This one right here is in the denominator, and it starts at 0.166, and it goes down. That's this line right here. This right here is this line right here that goes down. It starts at 0.166, and it's in the denominator, so it starts going down. This one right here is at the 1.88, which is 1.88, which is right about there, and it goes down. These happen right away. This in the numerator is at 40 because it's going up at the rate of the square. Yes, sir. What now? Oh, okay, yeah, okay. It's 0.531. Okay, I'm sorry. I am sorry. This I'm wrong. I'm thinking wrong. When this gets to 6, this one does not go at 1/6. This goes at 6. This goes at 1/1.88. So this is it's what's in the denominator, and I forgot about that. It's what's in the denominator is where it goes. I'm sorry. This line is wrong. I'll do it again real quick. I'll do it again. This is wrong. I did it wrong. Sorry about that. We'll get it. Sorry, we'll get it. Okay, so it's an image. Okay, so it's where it goes to. All right, sorry about that. Okay, so let's go back. It's where it goes. It's where this number is. It's where the break is. So it's the number in the denominator is where the break is. So I all of a sudden flipped it around, and I shouldn't have. Good eye. Okay, so let's go back at the black color. Okay, so here's my 0 line, and my brakes are at 1.88 and so here's my 1, my 0.1, my 10, my 100, my 1K, et cetera, et cetera. Here is the one that starts at 10, 20, 30, 40. So this is the one that goes up at, this is my S squared term, okay? Like that. And that's, you lay a ruler across it and it looks basically like that, although I'm sloppy. Okay, that's my S squared in the numerator. Now in the denominator, it turns out that you do one at 1.88, which is right here. 1.88, which is, this is 2, so it's about right in there. And this one goes down at 20 dB per decade, so you find 10.88 right about here, so you go down like this, okay? And here is the 6, 2, 3, 4, 5, 6, and this one goes down at that same rate. Okay, now I can add these three, and I've got the 40 as my offset. So let's do the 40 in red. So I've got my 40, 20, 30, 40. Now let's turn to the blue and add these together. So I start here at 0 because I got a 40 and I got a minus 40. So I start here and I'm going up at a very high rate. So I go up at this rate. I go parallel to this line, which is like doing this, okay? Until I get to here, which is at 1.88. And at that point, I lessen my rate. I go at the same rate as I do this until I get here, and then I flatten out. There it is. That's the right answer. So it is, until I get to 1.88 is at 40 dB per decade rise, then at 1.88 to 6, it is at 20 dB per decade rise, and then after that, it's flat. That's the right answer. Sorry about that. So that gets you 3 of them. All right? So I will shut this off, and we'll practice this more on Tuesday, and we will be done with this. This is not going to take you a lot of time. I'll bring more sheets of paper, and if you want to burn more sheets on your own, you can, but I'll bring you more color ones. The homework is up here that was graded, and there was one lab with no name on it. So you got your name on it? Okay, so you're all, okay, so all's